Hey YouTube, it's been a while. I have been busy with a lot recently, but my schedule is finally starting to open up, so let me show you what I've been working on. So here it is. It's a VR desktop streamer, so that means if I want these windows out in my VR space, I can have it search for devices on my network, and you can see it finds my PC. Pair that with my not well-designed UI. Now we can see over here, so now we just go over to this window, and it shows us all of the windows that are currently open. We can open up as many as we want, but at some point here they're going to start crashing out on us because I haven't actually done anything to like balance bit rates or whatever, and there is a random crash bug as well. But yeah, we can open up as many monitors and applications as we want, and random crash bug. So you may be asking, why do I need to create my own desktop streamer instead of using an already existing one? Well, hubris. Actually, it's because I've been working on attempting to create a completely mobile, full desktop VR setup. The ultimate portable PC with a 10-liter PC case. A 6E router for streaming to headsets anywhere in the globe. A drawing tablet for easy transportation, not the one shown here. And an Apple Vision Pro, so I can use 52 monitors from a hotel room. But you see, that's the issue there, is the multiple monitors thing. Every desktop streaming application on the current Apple Vision App Store has one of three problems. One, it's overly expensive. Two, it has a subscription. Why am I going to pay a subscription to see my desktop? That makes no sense. Or three, it only works for one type of computer. It either only works for Windows or it only works for MacBooks. In my mind, I should be able to do either or even both at the same time. What is the obvious solution? Well, obviously, I just build my own desktop streamer app. So that's not too hard. I'll just set up a FFmpeg or GStreamer pipeline and then just create a quick wrapper application to pipe all of those together, and it'll just be that easy, right? Well, that's what I tried first. I got GStreamer all up and running with an RTMP stream, I believe. And it worked. But it also had like half a minute of latency no matter what I did. And I just really couldn't get the control over the application that I wanted to make this as seamless of an experience as I wanted to. So I did a very sane thing. I decided that instead of using a pre-existing tool like GStreamer or FFmpeg, what I should do is directly interface with the media libraries on both the target and end devices. So on the computer side, I actually kept it simpler. I did just use libav codec from the FFmpeg project, but without actually using FFmpeg. We're just importing libraries and then manually calling all of the encoder functions. And then on the Apple Vision Pro side, I was originally going to use Video Toolbox and then actually figure out how to do like the graphics swapping of textures and whatnot. Turns out they have a video component that can just accept raw nail packets, which is what videos are encoded into, with just little tiny packets of information. That made things significantly easier when it wasn't tripping me over. When it wasn't giving it. When it wasn't. So yeah, custom clients everywhere. Build everything from scratch. Not really, but build everything from scratch. Obviously, the easiest way to get my clients on the Vision Pro and on the desktop to be able to talk to each other is to create a common transport library in Rust and then create some Objective-C bindings. And then, yay, now my Rust-based desktop app and Vision OS Swift client can talk to each other super easy, right? No. Don't ever try to FFI Rust into other languages if you can avoid it. Just don't. It's not worth it. To give you a brief overview,
On the Rust side, you have to create a bunch of macros to create no-mangle public extern-c functions for all of your results and promise types. That is, if you want to have type-safe result and promise types, which I did because I'm an absolute madman. And then you have to create a bunch of wrapper functions for some other miscellaneous functions that don't really matter, like cleaning up memory and whatnot. And then you have to go over to the Objective-C side and create essentially exactly the same thing over here, where you create a ton of macros, call those macros for all the same types, making sure everything's named exactly the same, copy over all of those extern C functions over here, and then over on the Swift side of things, because you can natively use Objective-C functions from Swift, but it's not type safe, and now it's like Objective-C coded in Swift, and Swift has like automatic memory management-esque stuff going on there. So what I did is I wrote an entire Python class to automatically generate functions for all of those macro functions, because Swift doesn't have a generic system that's good enough to do these. So yeah, we'll just write an entire Python class, or Python function, or script, Python script, to make classes to encapsulate all of these types you see here.
And yeah, I'm not going to spend any more time on that, because it's not worth it. But anyway, so now we have a way to send data across between the two or more clients. That's just a default C library that you can import to any language. So technically I could import this into Unity and do a Unity application for, say, a Quest headset in the future, but for now it's just AVP. But yeah, now that we have that common way to send data, essentially our network protocol, to replace like RMTPS or whatever, now we're just using our own, how are we actually encoding video? Well, since I spent a fair amount of time in GStreamer, I was inspired a lot by the way it and FFmpeg handled their pipelines, with several stages connected by common data types. Since I wanted this to be cross-platform, it's important that all of the encoding steps are as modular as possible, since I wanted to eventually use the best pipeline for the job on each individual platform. For now, x86 from libav is the only one I've implemented at the moment, as it is a good fallback and easier than having to deal directly with vendor-specific GPU APIs like NVIDIA Encode. But because of the way I encoded this pipeline, swapping it out would be as easy as writing a struct that implements the encoding session trait. The other reason it's coded this way is because I ended up trying out every single Windows capture method. First, generic print screen. Yes, this is the exact same as pressing Alt print screen on the keyboard. And then I added on the display duplication API for more efficient monitor capture. Then, once all of that was working, mostly, I found WGC, or the Windows Graphics Capture API. That allows you to capture both full monitors and single windows with the same system. Truly a Windows moment. Eventually, after a lot of debugging and a custom async data type, it was almost working, but it was still really laggy. I added a ton of debugging in different areas of the pipeline, but no matter what I did, all I could tell was most of the time everything was working amazingly well. Then, as a complete guess, I commented out the code that was supposed to keep the video in sync with the stream by speeding the video up and down, and magically it started working. Turns out the mere act of setting the playback speed of an AV sample buffer display layer lags the entire thing out slightly, and I was setting it every frame, so it was lagging out quite a bit. So I needed a better solution to maintaining a solid delay between when a frame is recorded and when it's displayed. It was harder than I thought. Since we're dealing with two devices here, there's not an easy way to sync sub-millisecond timestamps. When I was trying to find one, I stumbled across NTP, or Network Time Protocol. This is what every device in the world uses to sync its clock. At the most basic level, you send messages back and forth between server and client, and do some really simple math to account for latency. I threw a jank version of that into my networking library, and voila! What I haven't benchmarked yet, but I hope, is a sub-millisecond synced clock. Now, I can't set the speed of the video player to adjust the buffer latency, so how are we going to control that? Simple. Just take the difference between the time the screen is playing and the synced clock, and then add that value to a timestamp on every frame that gets set when it's recorded. Now to change the latency, all I need to do is subtract from that offset. Simple. And that brings us to where we are today, where I have a mostly working desktop streamer that needs a lot of polish, has some random bugs I still need to figure out. Basically, there's still a fair amount of work to it. But this is the part in the video where I talk about my plans for the future. And the plans for the future don't actually include this project, which is a little disappointing for me, may be disappointing to the viewer as well, because you just watch me explain this and I'm excited the whole time, except when I got a little less excited because I was reading off of a script, because I had this realization halfway through making this video, so that kind of tempered the mood. Anyway, what I realized is what I really want to be doing in life right now is pursuing this YouTube channel. And to do that, I really want to be focusing on the projects that make the most sense for this YouTube channel. And the desktop streamer, while incredibly cool, was originally because a few months back I had decided that I was going to go fly out to Spain and work in Spain for a little bit. Those plans ended up falling through. So like my mobile PC setup, the whole Apple Vision Pro desktop thing is like unnecessary at this point. Like I'm gonna keep the PC small because it is amazing to have like a super tiny PC. A very good mobile PC is just very nice to have. But I don't technically need this headset anymore. And this project was essentially my justification to keep it around, but I don't think it's ever going to make enough money to actually pay this off, which means it doesn't make sense for me to keep it anymore. It's amazing to be like, oh yeah, I can do all the desktop monitors, but like, I don't need it. And what I would be using the funds from selling this multi-$1,000 headset off would be going all in on this YouTube channel. Basically, I realized what I want to be doing in life right now is working on my game engine and the scripting system for it, because I have so many ideas that I've been holding on to for the last 2 years, and I just haven't had the time to explore them. And fully pursuing a YouTube channel for the next 6 months, just to see if it works, would give me the chance to do exactly that. So, that's what we're going to do. We're going to try this out for 6 months and see if it works. And I put a lot more effort into this video than I usually do, and it's not as much effort as I want to put into videos in the future. I want to put even more in. Animated graphics, the whole deal. So yeah, we will see where it goes. But next video, expected out in a couple weeks, and that will be the start of our journey into madness working on BrainScript 2.0. I will see you there.